Hello students, welcome to the cbse chemistry lecture series. The last video we discussed about few electronic effects like inductive effect, electromagnetic effect and resonance effect. Today we are going to discuss about hyperconjugative effect. The hyperconjugative effect is otherwise known as no bond resonance or Baker-Northern effect. Now let us discuss what is meant by hyperconjugation effect. So normally in the last class, in the inductive effect of the alkyl groups on a saturated carbon chain follows this order. You can think about the tertiary order. 3 times C is greater than CH3 twice CH is greater than CH3 CH2 is greater than CH3. So this is the order, yes, for the inductive effect. This is for inductive effect. However, when an alkyl group is attached to an unsaturated system, the unsaturated system is nothing but carbon-carbon double bond or a benzene ring. The order of inductive effect is actually reversed. That effect is known as hyperconjugation effect or Baker-Northern effect. So now let us discuss detailedly what is hyperconjugation effect. In fact, the hyperconjugation effect is an extension of a resonance effect. Actually, if we talk about the hyperconjugation effect, is nothing but it is a combination of the inductive effect sigma bond and the pi bond. Whereas the resonance effect involves the delocalization of pi electrons of a double bond and non-bonding electrons. Whereas here it is a delocalization of what sigma electrons through the overlapping of p orbitals of a double bond with a sigma orbital of a adjacent sigma bond. That I will explain by a graphical representation as well as what the diagram. You can think about CH3 1, 2, 3. This is one more hydrogen atoms. This is an orbital. When this another carbon having 2 hydrogen atoms. So here the p orbitals, okay, whereas here this is a sigma bond, the bond between the carbon and hydrogen. Here it is a p orbitals. So this is actually a pi electronic system or double bond, carbon-carbon double bond systems. In this case, we are having this is a pi bond, and here there is an interaction between the sigma and pi conjugation. Here there is an interaction between the sigma and the pi conjugation. So this is the orbital representation of a hyperconjugation, sigma pi conjugation. Okay. In terms of structures, you can think about the CH3 CH double bond CH2. So this is a propene. Here we will take a structures like this: H, 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 C, H, double bond CH2. So here in this case the carbon hydrogen is a sigma bond. There is a shift of what? The sigma bond with the pi electron systems. That's why it shifted to form a double bond. This will become a minus charge. We can write the structures like this. Here the sigma bond is shifted to here to form a double bond, and this double bond becomes a minus charge on the carbon atoms. So you have to draw like this. So CH, and there is no hydrogen. That is what? There is no bond between this carbon and hydrogen. It will become a double bond, and this CH2 minus. Here, why this hyperconjugative effect is called as a no bond resonance means here the carbon atom and the hydrogen atom, there is no bond existing, even though it is these structures we can call as what? Hyperconjugative resonance structures. We can write another similar word, resonance structures also for this hydrogen atoms. So if we shift this one, yes, now there is no hydrogen bond between this hydrogen and this carbon. If you write another structures, Here it will be forming a like this one, carbon, hydrogen, hydrogen. Here there is no what? Here these 3 hydrogen atom having a resonance structures. This will make the structures more stability. Okay, so it may be noted that although a free proton has been shown in the above structures, it is still bound quite firmly to the pi electron cloud, and hence no free to move. So it will not free to move anywhere, these hydrogen atoms. So it is evident from the structures that hyperconjugation occurs through hydrogen atoms present on the carbon atom to the next to the double bond, that is alpha hydrogen atoms. Naturally, more the number of what? Such alpha hydrogen atoms. Alpha hydrogen atoms means more the number of conjugated structures. More alpha hydrogen atom means more conjugated resonance structures. Clearly the number of hydrogen atom is 3 for this methyl group. Therefore what? This is what? We can say it is what? More stable. The another one is for ethyl group. If it is a ethyl means only 2. If it is isopropyl means only 1. Whereas the tertiary butyl there is no hydrogen atoms. Thus the order of hyperconjugative effect decreases in the order. First is what? CH3 is what? Greater than CH3 CH2. Ethyl group is greater than CH3 twice CH. Isopropyl is greater than tertiary CH3 3 times C. So this is the order for hyperconjugate effects. Just reverse of inductive effect. Hyperconjugative effect in the decreasing order. Okay. Next we will discuss about the significance. The first significance is directive influence of alkyl groups. What is the meaning of this directive influence of alkyl group? Means suppose in the ortho and para directing groups, the ortho and para directive influences of CH3 group can be easily explained. As follows. I will explain to you. You can think about toluene structures. C, H, H, H. So if you write a resonance structures of these things, what will happen? This will become shifted to forming a double bond here, and this will become a minus charge. So you got to draw like this. Minus double bond C. There is no bond between this carbon hydrogen here, and these two pi bonds as such. If you write another structures like this, means how can you write these structures? Here you got to explain this one. Yes, we can also write 2 more structures. So as a result of this hyperconjugation, the electron density at ortho and para positions with respect to the CH3 group increases, and hence the electrophilic substitution reactions in toluene will occur at ortho and para positions with respect to the CH3 group. That is the first applications. The second application is shortening of carbon-carbon single bond adjacent to multiple bond. So I will take an example like propene. You can number the carbon atoms as 1, 2, 3. Okay. So here there is a shift of what? Sigma electrons to here, and what will happen? This will become a minus charge. So you got to write the resonance structures. So C, H, H, and no bond between this H plus and the H, double bond C, H, CH2 minus. Here in this case, because of the hyperconjugation, the C2 and C3 single bond single bond acquires some double bond character, and hence it's little shorter. Hence it is little shorter. For example, it is 1.49 angstrom, the carbon-carbon double bond, whereas the normal carbon-carbon single bond is 1.54 angstrom. So that is why the bond is what? Little bit shrinking, or you can say shortening. So that is another applications. The next application is what? Relative stability. Relative stability of alkenes. Say for example, you can take an example like CH3, C, CH3, double bond, C, CH3, single bond CH3. It is actually a 1, 2, 3, 4, 2, 3 dimethyl butene. Okay. So in this case, the another one structures CH3, C, CH3, double bond, CH, CH3. Then another one structures CH3, CH, double bond, CH3, H. The another one structures CH3, C, H, double bond, C, CH3, H. So if we compare all these alkenes, the stability of alkene of, say for example, the cis and the trans 2-butene, cis and trans 2-butene, if it is a the trans 2-butene is what more stable than the cis 2-butenes. Here, in which the two methyl groups electronic clouds are repel each other in this case. So that is why it's what more stable. That is another applications. The fourth application, that is what? The stability of carbocations. Stability of carbocations and free radicals. So in this case, we are going to talk about the carbocation stability. Due to the presence of hyperconjugative effect, when we comparing the primary, secondary, tertiary groups, like what? CH3 twice CH, then CH3 3 times C. So when we comparing these three, so which is more stable and what is the reason behind this one? That is due to hyperconjugative effect. So the tertiary is what? More stable than the secondary, more stable than the primary. Yes, when we comparing all these things, so this is the order. Okay. Suppose if it is a free radicals also, you have to think about CH3 3 times C dot is greater than the CH3 2 times C H dot is greater than CH3 CH2 dot is greater than CH3 dot. If you talk about free radicals, this is the order because due to the presence of hyperconjugative effect. Thank you, students. If you have any doubt, please mention in the comment box. Thank you, students.